In this video, I'm going to do a bunch of integrals that you should be able to do by the end of a Calculus 1 class. So this is going to be a review. I'm going to tell you some tips and tricks to do well. So let's get started. We're going to start off nice and easy. So number one, we have an integral from 0 to 1, 1 minus x to the power of 9 dx. Now this is just a polynomial function, so we can integrate term by term, and this 1 can be written as x to the power of 0. Now the reason I write it like this is because we use the power rule. To get the antiderivative, we bump up the exponent by 1 and divide by that same number. So the antiderivative is x to the power of 1 over 1 minus x to the power of 10 over 10. And this is evaluated from 0 to 1. Now x to the 1 over 1 is just x. So if I plug in 1 for x into both terms, I get 1 minus 1 over 10. And now minus, I'm going to plug in 0 to both terms now. So this is just 0 minus 0. So this doesn't change anything. So the answer here is going to be 9 over 10. So that's the first one. Next up, number 2. We have an integral from 0 to 2 of y squared times the square root of 1 plus y cubed dy. Now, I'm going to make use of a u substitution here. So we set u equal to the function that's inside another function. So in this case, the function here we're going to set u equal to is 1 plus y cubed. So the entire function that's inside of the square root function here. So what we do now is we take the derivative of both sides with respect to y equals d dy of 1 plus y cubed. Now, the left side is du dy, and the right side is going to be 3y squared. Now, I multiply both sides by dy, so I have du equals 3y squared dy. Now, if I look at the integrand here, I don't have a 3, so I'm going to divide both sides by 3. So I have du over 3 equals y squared dy. So this y squared and this dy will be replaced with du over 3. So this is equal to the integral of square root of u and then du over 3. Now to get the corresponding limits in this new integral here, I have to plug in the old limits into the substitution here. So in dy, the lower limit is 0. So if I plug that in for y here, 1 plus 0 cubed is just 1. So the corresponding lower limit in the new integral is 1. And if I plug in the upper limit into this here, I get 1 plus 2 cubed. That is 9. So 1 over 3 is a constant. I can bring it out in front. So integral from 1 to 9. And then if I replace the square root with the fractional exponent, this is u to the power of 1/2 du. And now I use the power rule again. I bump up the exponent by 1, so this is going to be u to the power of 3/2. And if I divide by 3/2, this is multiplied by 2 over 3. So this is the reciprocal. And this is evaluated from 1 to 9. And this here is going to be 2 over 9. And now 9 to the power of 3/2, and then minus 1 to the power of 3/2. Let's see, so the square root of 9 is 3. 3 raised to the power of 3 is 27. And now minus 1. So this is 2 over 9 times 26. This is equal to 52 over 9. And this will be our answer. All right, let's move on to the third integral that I have here. Number 3. So I have an integral of x over x squared plus 1 dx. Now this is an indefinite integral. There are no limits of integration here, so that will affect our final answer somewhat. So so when we have a fraction like this and we want to do a u substitution, we set u equal to what's in the denominator most of the time. So I'm going to say I'm going to set u equal to x squared plus 1. Now, if I take the derivative of both sides, d dx, u equals d dx of x squared plus 1. On the left, I have du dx equals 2x. And if I multiply both sides by dx, this cancels, and I'm left with du equals 2x dx. Now, I don't have a 2 in this integrand, so I divide both sides by 2. So that I have du over 2 equals x dx. So this x dx here will be replaced with du over 2 in the new integral. So integral 1 over u and then du over 2 is the new integral. 1 over 2 is a constant. I can bring it out in front. 1 over 2 integral du over u. This is 1/2 ln u, or natural log, plus c. C is a constant. It's included in every indefinite integral, and it's something that's very easy to miss if you're not careful. So, all right, so we were given an integral in terms of x, so our final answer has to be in terms of x as well. So after the integration is done, we revert back to the original variable here. So our final answer is going to be 1/2 ln absolute value x squared plus 1 plus c. Now the thing is that this absolute value is included because the argument of the natural log has to be positive. The domain of the natural logarithm only allows for positive numbers, so that's why I have an absolute value here. But x squared plus 1 is always positive because x squared is always positive. So I can drop the absolute value sign. So we can write it as 1/2 ln x squared plus 1 plus c. And this here is our final answer. All right, number 4. Let's see. So our integral here is integral from 1 to 5 dt over t minus 4 raised to the power of 2. So as I said, we would, to solve this, we make a u substitution. I'm going to set u equal to the function that's inside of another function, so t minus 4. However, before we continue, this integral is actually a trick question because the denominator is t minus 4, and the limits of integration go from 1 to 5. You see what happens if we plug in 4 for t? The denominator goes to 0, and the integrand blows up. So when t is 4, which lies within these limits, the integral blows up. So this integral actually diverges. So yeah, before you do any work, always check to see if the denominator goes to 0 for, when you plug in values of t between these limits of integration. So yeah. All right, number 5. I have here the integral from -1 to 1 sine x over x squared plus 1 dx. Now this is very similar to what we had here, I set u equal to x squared plus 1 on the bottom. However, and we found that du is going to be 2x dx. But the problem is that in the numerator we have sine x, which is a completely different function. So there's actually a trick to this problem here. And so there are two things. One is that if you replace x with negative x, we get the same integrand but with a minus sign. So the integrand is an odd function. So this here is an odd function. And the limits of integration are symmetric about 0, meaning that it's we have negative a number, and then the upper limit is positive that number. So so straight away we can say that this is equal to 0, because this is a very specific situation where we have the integral of an odd function over a symmetric interval from -1 to +1, or it could be -3 to +3, as long as that interval is symmetric and the integrand is odd, it's equal to 0. So if the integrand looks like something that you can't really do, look to see if this situation applies. All right, let's move on to number 6. We have here the integral of dx over x squared plus 1. Now this is very similar, but here we just have x squared plus 1 on the bottom. So fortunately or unfortunately, this is something that you have to memorize. And this is from a table. This is the inverse tangent function plus c. Plus c is important because this is an indefinite integral. Always have the plus c. All right, number 7. I have here the integral of x plus 2 over square root x squared plus 4x dx. So again, I have a fraction here. I'm going to look to set u equal to something in the denominator. In this case, I have a function within a function. So I set u equal to x squared plus 4x. Now, the reason I don't include the square root here is because we always use the function within the function. So even though, so we wouldn't just set u equal to the square root of the x squared plus 4x. Otherwise, when we take the derivative, it's going to be very complicated, and our integrand doesn't have that complicated function. So take the derivative of both sides. So this is x squared plus 4x. On the left, we have du dx equals 2x plus 4. And I can factor out a 2 here, so this is 2x plus 2. And if I multiply both sides by dx, I get du equals 2x plus 2 dx. Now, I don't have a factor of 2 in the integrand, so I'm going to divide both sides by 2. So du over 2 equals x plus 2 dx. So in place of this, I'm going to have du over 2. So the integral becomes 1 over square root u. That's here in the bottom, and du over 2. I'm going to bring the constant 1/2 out in front, and I'm going to replace the square root with a fractional exponent. So this is u to the power of -1/2 du. This negative here is because it's 1 over the square root of u. So I use the power rule once again to integrate this. This is going to be 1/2. I bump up the exponent by 1, so that's positive 1/2, and I divide by that same number. If I divide by 1/2, that multiplies this by 2. So this 1/2 cancels with this 2. And again, the integral was given in terms of x, so my final answer has to be in terms of x as well. So now that the integration is done, I change back to the original variable here. So, oh, also plus c, can't forget that. But yeah, this is a square root of x squared plus 4x and then plus c. So this here is going to be our final answer. All right, let's move on to number 8. I have here the integral of sine x times the cosine of cosine x dx. All right, so I'm going to set u, I'm going to follow my guideline here and set u equal to the function that's within another function. So here I have the function cosine x within another cosine function. So I'm going to set u equal to cosine x. And if I follow the same procedure, I take the derivative of both sides. And on the left, I have du dx, and the derivative of cosine is minus sine x. And now I multiply both sides by dx to get du equals negative sine x dx. Now I don't have a negative sign in this integrand, so I'm going to multiply both sides by -1. So negative du equals sine x dx. So this sine x and this dx here will be replaced with negative du. So this is equal to integral. This cosine is not affected by this change of variables here. So cosine of u and then multiplied by negative du. So the -1 is a constant. I can bring it out in front. So this is equal to the negative integral of cos u du. This is equal to, so the antiderivative of cosine is going to be sine. So negative sine u plus c. And now that the integration is done, I replace u, I change back to the original variable. So this is equal to negative sine of cosine x plus c. And that's our final answer. All right, moving on to number 9. I have here the antiderivative of e to the power of square root x over square root x dx. Just making sure I put dx on this one as well. All right, so because I have a fraction here, I would look to, I would set u equal to something in the bottom. However, we also have a function within a function. We have e raised to the power of square root x. So it just so happens that what's inside the function is the same thing as what's on the bottom. So u equals square root x. And now I'm going to take the derivative of both sides. U and then equal to d dx of square root x. So on the left, I have du dx equals, so this is d dx of x to the power of 1/2. So this is, let's see, 1/2 x to the negative 1/2, which is 1 over 2 square root x. And if I multiply both sides by dx, I get du equals dx over 2 square root x. But I don't have a 2 in the integrand here, so I multiply both sides by 2. So dx over square root x will be replaced with 2 du. So this here is going to be the integral of e to the u and multiplied by 2 times du. 2 is a constant, so I can bring it out in front of the integral. So this is 2 integral of e to the u du, and the integral of the exponential function. the integral of an exponential function is the exponential function. So this is 2 times e to the u plus c. And now that the integration is done, I change back to the original variable. So this is equal to 2e to the square root of x plus c. Number 10. Oh, I'm out of space, so we shall open. Alrighty. Number 10. I have here the integral of tan x ln of cos x dx. Now, I would set u equal to the function that's within another function, in this case, cos x. However, du is going to be equal to negative sine x, and what I have outside is tangent x, which is not sine. So this is one example where our guideline leads to the wrong substitution. What we should do instead is take the entire function here to be u. So u, if I set u equal to ln cosine x, now if I take the derivative of both sides, d dx, u equals d dx of ln cosine x, I get du dx on the left. Now the derivative of natural log, that's going to be 1 over whatever's inside here. So that's cos x. And now I multiply, I have to use the chain rule. So I multiply by the derivative of what's inside, which is cos x. This is minus sine of x. 1 over cos x times minus sine x. So negative sine x over cos x, that is equal to negative tangent x. And if I multiply both sides by dx, I get du equals negative tangent x dx. But I don't have a minus sign in this integrand, so I multiply both sides by -1. So negative du will replace tangent x dx in this integrand here. So this is equal to integral. Let's see, so u is going to be all of this, and the tangent x dx will be replaced with negative du, like this. The negative sign is, the -1 is a constant, so I can bring it out in front. So this is negative integral u du. This is negative u squared over 2 plus c. And now that the integration is done, I change back to the original variable. So this here is negative 1/2 ln cos x squared plus c. And this here is our final answer. All right, number 11. I have the integral of x over square root 1 minus x to the 4th dx. Now, so if I follow my own advice of setting u to be the function within a function, that would be 1 minus x to the 4th here. But if I take the derivative of both sides, I get du equals negative 4x cubed dx. The problem with this is that in the numerator, I only have 1x, whereas here I have 3 of them. So this u is not going to work. So what do we do here? We have to see if we can simplify this, the denominator somehow. So recognize that this is a difference of squares pattern. So I can rewrite the denominator as x over square root 1 plus x squared times 1 minus x squared dx. Now you might think, okay, let's let's try u equal 1 plus x squared. So if I do that, I get du equals 2x dx. And if I divide both sides by 2, yeah, so this is not going to be the correct choice for you. So instead, what we should do is replace it with, what we should do is u equals x squared. See, by replacing u with 1 plus x squared, we sort of, we simplify one term, but we make another term more complicated. So by just using x squared for u, both terms will be similar. So du will be 2x dx, and divide both sides by 2. So this integral here will be equal to 1 over square root 1 plus u, and then 1 minus u times du over 2. Now 1/2 is a constant. I can bring that out in front. So 1/2 and then integral. This is going to be du over square root 1 minus u squared. Now this integral here is another one that's in the table of integrals. So it's something that you have to memorize, unfortunately. So this is going to be 1/2 inverse cosine, or actually, no, this is negative inverse cosine of u plus c, again, because this is an indefinite integral. And now that the integration is done, we change back to the original variable, which is x. So our final answer is going to be negative 1/2 inverse cosine of x squared plus c. Okay, number 12. We have here the integral of x over x minus 3 dx. So this function can't be integrated as it is. So again, I'm going to set u equal to what's in the denominator here. So this is u equals x minus 3. So take the derivative of both sides. D dx of u equals d dx of x minus 3. Left is du dx. The right side is 1. So du equals dx. So this integral becomes, oh, I need to know what x is. To do that, I have to solve this equation here for x. So this is going to be u plus 3 equals x. So u plus 3 is in the numerator, and on the bottom, x minus 3 is u. And dx, I can replace it with du. Now the point of writing it like this is because we can actually simplify this fraction. This is the sum. This is u over u plus 3 over u. I can split up the fraction into 2. That's how addition of fractions works. So this here is the integral of 1 plus 3 over u. So this is u plus 3 ln u plus c. Now that the integration is done, I change back to the original variable. So this is equal to x minus 3 plus 3 ln absolute value x minus 3 plus c. And this here is going to be my final answer. I can combine this negative 3 with the c here to get x plus 3 ln x minus 3 plus d, so a new constant. This could be another way to write your answer. All right. Number 13, I'm going to wrap up with some integrals of absolute value functions. So integral of 0 to 3, absolute value of x squared minus 4 dx. Now, the absolute value function cannot be integrated, so we have to rewrite that in terms of functions that we can integrate. So we have to look at this function that's inside x squared minus 4 and see where it's positive and where it's negative within these limits of integration from 0 to 3. When x is 0, 0 minus 4, that's negative. And when x is 2, 4 minus 4 is 0. So from 0 to 2, this should actually be 4 minus x squared dx, and then plus 2 to 3, and I leave it as it is because x squared minus 4 is positive within these numbers, 2 to 3. And now that the absolute value is gone, I can just integrate these polynomials. So this is going to be 4x minus x cubed over 3, evaluated from 0 to 2, and then plus x cubed over 3 minus 4x, evaluated from 2 to 3. So this here is going to be 4 times 2, 4 times 2 minus 2 cubed over 3, minus, if I plug in 0 for x in both terms, I get 0. And now this one here, that's if I plug in 3, that's 3 cubed over 3 minus 4 times 3. And then minus, I plug in 2. So 2 cubed over 3 minus 4 times 2. All right, so this here is going to be 8 minus 8 thirds plus 27 over 3, which is 9, and then minus 12 minus 8 thirds minus, or no, plus 8. All right, so let's see, 8 plus 9, that is, or yeah, 8 plus 9 is 17. 17 plus 8 is 25. So I have 25 minus 12 minus 16 over 3. So this is 13 minus 16 over 3. This is 39 over 3 minus 16 over 3. This is 23 over 3. And this here is our answer. Okay, one more. Number 14. Another absolute value function. We have here the integral from 0 to 4, absolute value square root x minus 1 dx. Okay, so again, we have to we can't integrate an absolute value function directly. So what we do is we look at the function that's inside and see where it's positive and negative within the interval from 0 to 4. So if we plug in 0 for x, we get 0 minus 1, that's a negative number. If we plug in 1, the square root of 1 minus 1, that's 0. So we write this from 0 to 1. This is going to be, we multiply this by negative 1, so 1 minus square root x dx. And then the rest of the way from 1 to 4, we leave it as it is, square root x minus 1 dx. If I plug in 1 for x, that's 1, so that's the integrand is 0 in that case. And then 4, square root of 4 is 2. 2 minus 1 is 1, so that's positive. So this is fine. And now that the absolute value is gone, I can proceed with the integration. So this antiderivative here is x minus x to the power of 3 halves multiplied by 2 thirds evaluated from 0 to 1, and then plus square root 2/3 x to the power of 3/2 minus x, evaluated from 1 to 4. Now, if I plug in the upper limit here to for x here, this is going to be 1 minus 2/3. And if now I subtract the same thing, but I plug in 0 this time. This is just 0. All right, and now the second one here. This is if I plug in 4 here, 2/3. So square root of 4 is 2, and 2 cubed is 8, and minus 4. And then minus, I'm going to plug in 1. So this is 2/3 minus 1. And now I just evaluate this. So this is 1/3 plus 16/3 minus 4. And then minus negative 1/3. So this is 2/3 plus 16/3 minus 4. This is 18/3 minus 4. That's 12 over 3. So this is 6/3, which is 2. So this is going to be our answer for this integral. Thanks for watching all.